In this video, we're going to break down decentralized file storage and cloud computing and deep dive into one protocol called Arweave.org. Before we get into this concept of decentralized file storage, let's break down the current standards right now, which are protocols such as IPFS, which stands for Interplanetary File System. With IPFS, it's a distributed system for storing and accessing files, websites, applications, and data. Let's break down how IPFS works in this example. I'm going to head to IPFS website and we're going to go ahead with this aardvark example. If I were to go to their website, we can try entering in the typical Wikipedia URL, and I'm going to enter this in my browser right here. We can look at the second example, which is an IPFS, and there's a ton of numbers, and then at the end there's a wiki aardvark.html. I can also paste it in my browser. You can see I have access to the exact same data, except the first URL is held on Wikipedia servers. With the second, it's held on a distributed file storage system called IPFS. The cool thing is, if Wikipedia had shut down their page, you would still be able to access the file via IPFS. So in this example, if this aardvark page suddenly went down, I can always access it via IPFS. But there's a couple of problems. You'll notice this within non-crypto open source protocols, which are misaligned or non-existent incentives. People are actually the ones who store the data on IPFS using what we call a node, and if there's ever a case in which nobody is hosting this aardvark data, it's removed and you won't be able to access it. So in some cases, you can see how this is a problem. If this Wikipedia page of this aardvark or Wikipedia itself ever shuts down, and if the IPFS data isn't pinned to a provider, and it's usually pinned to something like Amazon S3, which is a centralized storage system, the data disappears usually in a few days, as nodes have no incentive to persist. IPFS addresses lets you find a piece of content so long as someone, somewhere on the IPFS network is hosting it. So the key thing that you can take away is that if nobody is hosting the IPFS data, then nobody is able to access it. And this is a key problem, as a lot of people don't have an incentive to hold the IPFS data in the first place. If we're actually moving this to certain examples, you can see how dangerous this is to the world of non-fungible tokens, which are completely blowing up right now. If nobody is hosting the node for the IPFS data, it can be removed from the internet, where that simply means your NFT is nothing but a transaction on the blockchain without the content or metadata. Now, a great account is called Check My NFT, and I'm going to screen share really quickly, and I'd suggest for you to follow them. I just found that it was really good source to be educated on strict and proper NFT purchases and what you should actually link for. One great breakdown that they have is on Cent, which is a marketplace where you can buy and sell tweets. And they talk a tiny bit about how Cent holds the metadata associated with each tweet. Now, let's talk about the solution. So now that we know some of the challenges with IPFS, this is where decentralized file storage comes in. And what if I told you that you never ever lose your data that you permanently want to have up on the web? There's a pretty cool range of companies involved in decentralized file storage, such as Sia and Filecoin. But in this video, we're covering Arweave, so let's get right into it. So what is Arweave? Founded in 2017 as Archain, the company changed its name to Arweave in 2018, and it's simply a way that you can store data affordably. Arweave is a decentralized protocol that connects people who have room in their hard drives with people who need to store data, and they verify this through a method called proof of access, which is similar to Bitcoin's method called proof of work. We won't cover proof of work, which Bitcoin uses in this video, but I would definitely suggest reading up on proof of work concepts if you haven't already, and I'll link some resources below. If I had to summarize, proof of work is simply a way that you're able to add data to a blockchain by referencing and validating the previous data that you inputted, and this allows for one source of truth. Arweave is also funded by some of the most notable venture capitalists, including A16Z, and in my opinion, probably the best venture firm for crypto, Union Square Ventures. So let's dive deeper into how the proof of access works. Proof of access is basically a mechanism in which the people who store data, which are called the miners, have to reference it to the previous data to add a new block. And this is very powerful because it's a collectively owned hard drive where everybody has access to the same file and data. Whenever you make another copy of the previous data as a miner, you also earn Arweave tokens, and this is the alignment of incentives with tokenization. So, as a miner, or as an Arweave miner specifically, unlike IPFS, you're incentivized to store data, making sure that the file lives on forever. Now, how does it work if I actually wanted to store data? On the user, or kind of the storage experience side, the user has to pay a one-time principal fee to store it on the Arweave storage server. A principal is the same thing as an upfront payment. This initial payment is then distributed to the miner who holds the data, and that's how incentives are aligned. There's also this really neat concept of purchasing power, where basically the cost of storage will decrease over time, meaning that your initial payment is worth more than tomorrow, the day after, and 100 years from now. If you're interested, this can also apply similar to Moore's law's concepts. The observation, which is that the number of transistors in a dense integrated circuit doubles about every 2 years, the miner on Arweave is someone who stores data, and you can start by going on their website here. You can run it on Windows, but it's not recommended. As a developer, Arweave has a bunch of great developer libraries out, and this is helping NFT marketplaces store data more securely on a platform like Arweave instead of centralized services like Imager or IPFS. And there's going to be ways that make this transaction smooth and seamless for the end user. Ultimately, this will grow the entire decentralized NFT ecosystem even further, as more people will have confidence with their NFTs not running away from the internet. Other than all of the important stuff that Arweave is doing with things like NFTs, I think that there's going to be so many important use cases outside of this space, particularly in being able to verify the one source of truth correlated with historical events. With the rise of tech like deepfakes, we want to be able to confirm plus verify that events in history actually happen, such as election misinformation, pandemic-related news, and other information that impact humans' history. We're done now, and thank you for listening. Feel free to subscribe if you want to no-nonsense crypto content, and see y'all next week.